How did I get here? Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. How did we get here? Calculus. That's how we got here. And today we continue the amazing journey that we are taking together. We are talking about rules for integration. Once again, thank you, Sir Isaac. Thank you, Gottfried. So, moving forward, here are some rules. These are available in your books. We've talked about some of them again. If I take the integral of a constant, it's going to be the constant k, kx plus c. We've talked about the power rule. The integral of e to the x is going to be e to the x plus c. 1 over x is the natural log of the absolute value of x, and we know that the derivative of the natural log of x is equal to 1 over x. The derivative of sine x is cosine x, hence the integral of cosine is sine, and so on. This is a little strange. Remember, the derivative of cosine is negative sine, so that's why we have to have a negative out here. So the integral of positive sine is negative cosine x. You will get used to these as you go. Here they are in a little chart form if you would prefer that. Those were the explanations. Those are available in your book. And here is what is available on your formula sheet. Okay. You can use your derivatives to get your antiderivatives, can't you? The integral of cosine x is sine x. The integral of e to the x is e to the x. The integral of 1 over x, you just have to remember the absolute value, and we'll talk about that in class, is the natural log of the absolute value of x. And then you have your standard integrals, okay? Your standard integrals. Okay, so let's get to some examples, shall we? Find the integral of x cubed minus 2x squared plus 5. So part A, we've done several like this, but it doesn't hurt to do them again. I'm just going to write equals so I don't have to rewrite the whole thing. This equals, remember, we're just going to add 1 and divide by the result. So that would be x to the 4th over 4 minus 2x cubed over 3 plus 5x to the 1st, because right now it's 5x to the 0 divided by 1, but we're never going to write that. In fact, that's probably the last time you're going to see me do that, plus c. And of course, the check is always to take the integral of this and make sure that you get the integrand. Okay? So the integral of x cubed minus 2x squared plus 5 dx is equal to x to the 4th over 4 minus 2x cubed over 3 plus 5x plus the constant c. Okay? Now, sometimes we need to rewrite, algebraically, rewrite the integrand to make it more approachable or accessible to us. For example, I know I can write 1 over x cubed as x to the negative 3, square root of x, x to the 1/2 power, and then I can just use my power rule. So this would be equal to, we're going to add 1, so that's x to the negative 2, and divide by that same thing. Minus, we're going to add 1, so that would be x to the 3/2 over 3/2, and don't forget your constant, plus c. Cleaning this up, this would be negative 1 over 2x squared. So I'm just writing that without a negative exponent. You don't necessarily have to do it. You could have written this as negative x to the negative 2 over 2, and that'd be perfectly fine. Minus 2/3 x to the 3/2, or you could rewrite that as square root of x cubed plus c. Okay? All right. Next example. What do we got here? Integrate with respect to x. Okay, so we're going to take the integral of sine x, 2 sine x, sorry, minus cosine x dx. Okay. I think the easiest thing with trig functions is just to think about what you take the derivative of to get what's in the integrand. Now the 2 has no bearing on what's going on, so I mean, you can, if you wanted to, you could rewrite this whole thing as 2 times the integral of sine x dx, just to be able to bring the 2 out front, but it's really not necessary because you can do it in your head. minus the integral of cosine x dx. These are equivalent. Okay, so this is going to equal to, and you have to ask yourself, what do I have to take the derivative of to get sine? Well, we know that if I have cosine x, its derivative is negative sine x. But I need to get positive sine x, so that's why the integral of negative cosine x is equal to sine x. Okay, so that gives me negative cosine x minus, and the integral of cosine x is sine x, because if I take the derivative of sine x, I get cosine x, plus c. And we should clean this up to negative 2 cosine x minus sine x plus c. Okay, so I'm going to rewrite this one as the integral of negative 2x to the negative 1 plus 3e to the x dx. Okay, so this is equal to, okay, I'm going to add 1, let's see, negative 2, I'm sorry, not the integral, sorry about that. So I would add 1, right? So I would have negative 2 x to the 0 over 0. Uh-oh, that is a common mistake, and you think it's not integrable. Well, I'm going to do this again, and hopefully you're going to recognize this. I'm going to write this as the integral of negative 2 over x dx plus the integral of 3e to the x dx. And hopefully you'll begin to recognize anything over x I'm going to rewrite as 1 over x. Otherwise, we will always run into this problem. Dx plus the integral of 3e, well, I'll put the 3 out in front. You don't have to, but I'm taking extra time on the other one, so why not? The other term. So this becomes negative 2 times the natural log of the absolute value of x, because the natural log of x is equal to 1 over x, plus, well, the integral of e to the x is e to the x, so that's 3e to the x, plus the constant c. Okay? All right, so let's see what's up next. Okay? All right, so here, I don't know if I want to try and use the derivative method of taking the derivative of the integrand to try and figure this out. And I see it's only squared, so that's pretty easily expandable. So I am going to rewrite that as the integral of, and I'm just going to FOIL this, so it would be 9x squared. And maybe I have to do a little bit of scrap work in my head. So 3x times 2x, what is that? 3x times, I'm sorry, 2 over x is just equal to, bam, bam, 6. So I'm going to have plus 6, so that's going to be plus 12, easy peasy, plus 4 over x squared. And I'm going to go right away write that as 4x to the negative 2, just to make my life easier. We want to be able to do these as efficiently as possible, especially if we have limited time on an exam. So equals, I keep writing the integral sign when I'm ready to go ahead and integrate. So I'm going to add 1, divide by the result. This is simply going to be 12x. And I'm going to add 1, so that gives me negative 1, and divide by the result. So I forgot the plus sign here. Plus c, and then I'm going to clean it up to 3x cubed plus 12x, and this is going to be minus 4x to the negative 1 plus c. Of course, you could write that as 4 over x. It doesn't matter. It only matters when you're going to evaluate it, or if they ask you for it to be in a specific form. And then the last example we'll do on this video, I'm going to rewrite this again. This is equal to the integral of, I'll go ahead and do the algebraic step for you, x squared minus 2 over x to the 1/2 dx. Okay, So I'm going to rewrite that. That's still going to be the integral, and I'm going to divide both terms by x to the 1/2. So that's going to be 2 minus 1/2, that's x to the 3/2, minus 2 over x to the 1/2 is just simply 2x to the negative 1/2 dx. Easy peasy. Well, now we're in business. I'm going to add 1 here, so that would be x to the 5/2. And I would really like you to, instead of writing over 5/2, I'd like you to immediately recognize if I'm going to divide by 5/2, that's the equivalent of multiplying by 2/5. Then I don't have to take that extra step. Minus 2. So if I am going to add 1, that becomes x to the 1/2. And I'm going to divide by 1/2, which is the equivalent of multiplying by 2, right? So then my plus c, cleaning it up, 2/5, x to the 5/2, minus 4, x to the 1/2, plus c. Of course, you could write this if you wanted to as 2/5 times the square root of x to the 5th power minus 4 times the square root of x plus c. All right, that's it for this video. We're going to do just one more, should be shorter, and we'll be right back.